Hello, this is Darren Pulsifer, Chief Solution Architect of Public Sector at Intel, and welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology. On today's episode, breaking down the barriers to high-performance computing with Alan Chalker from the Ohio Supercomputer Center. Alan, welcome to the show.
Thanks so much for having me, Darren.
Hey, this is kind of exciting for me because I don't get to interview people in person very often, but I'm in Columbus, I'm at the Ohio Supercomputer Center, and I get to sit right next to you. This is pretty awesome.
Yeah, I agree. It's been nice. It's been several years since we've been able to do anything quite like this.
So Alan, tell me a little bit about yourself. You're the Director of Strategic Programs. At Ohio Supercomputer. Tell me a little bit about your background, what got you into this first, and then we'll dive in on how you're going to break down some barriers so I can use your HPC cluster.
Sure. So I am the Director of Strategic Programs at OSC, which is a made-up title. My boss likes to say that he's the Executive Director of OSC, and he went to some of his peer directors and said, what do you call the person who is the catch-all utility infielder that does all the things that don't fit nicely in any of the other managers' groups? And that's basically what my responsibility is. So there's a lot of things in my portfolio that don't fit nicely in just kind of the other portfolios in terms of, we have a client services group, we have an operations group, things like that. I handle a lot of different things, some of which we'll talk about today.
Well, so where did you come from? You weren't born here at Ohio Super, or were you?
So I'm actually an interesting success story when it comes to workforce development and stuff. The story goes way. I was not born in Ohio, but I spent most of my childhood in Ohio, in southwestern Ohio, south of Dayton, Ohio. And when I was I'm dating myself, when I was a freshman in high school, this little organization called the Ohio Supercomputer Center was only a few years old. OSC was created in 1987 and had a summer institute for high school students to learn about supercomputers. And I was the third class of that program. And my colleagues like to make the
you were born here then.
Yeah, I know. They like to make the statement that they made the mistake of letting me in the building way back in the early 90s. And like a bad penny, I keep coming back.
You've never. Now, have you worked in other places? I mean, obviously you've worked in other places.
Yeah, so I got my undergraduate in electrical and computer engineering here at Ohio State University. And then I lived for 8 years down in Research Triangle Park, North Carolina, where I got my doctorate in biomedical engineering from UNC Chapel Hill. And then my wife and I wanted to move back to the Central Ohio area, was looking for opportunities. There was one that opened up here at OSC, and 18 years later, I'm still here. And
that is awesome.
Yeah. That
is really awesome. Well, all right. So tell me what's unique about what you guys are doing here, because as I heard about this on-demand and breaking down the barriers. I used to be in high-performance computing myself back at the turn of the millennium when the Global Grid Forum was kicked off, and I was all part of all of that. But you guys have something you new and unique here. You're kind of making it easier to consume HPC. Is that?
Yeah, I think we were just happened to be in the right place at the right time. And so what you're referring to is Open OnDemand, which is a NSF-funded project that we've been developing for many years. It's well over a decade, 15 plus years at this point. And so the genesis story of that is if you go back to the mid-aughts, these things became really popular, right? iPhones and cell phones and general consumers became comfortable with doing things online banking, online shopping, things like that. Well, inevitably, those folks started coming to supercomputer centers and research computing centers and saying, hey, can you make it easier for us? Why do we have to do all the command line stuff like you see in the hacker movies with the green text scrolling by?
Well, because that gives us geeks like me a job.
Yeah,
right?
Yeah, exactly. And so we did a very first web interface way back in 2006, 2007 with a collaborating company that we have just down the street called Edison Welding Institute. And it was an online welding simulation. Basically, what it did is it took some of the knowledge and workflows they already were doing for their customers using things like Abacus and meshing, stuff like that, and encapsulate that in a web page. One thing led to another. We then did a polymer one, then we did a general purpose one. We started, because we're not creative, we said, okay, we're going to bundle these together, and we created what we called OSC On Demand. Again, we're techies. We can't think
course,
of, So the old adage, no good deed goes unpunished. We started showing that at various conferences in the early teens to our peer centers, and they were all like, that's amazing. We've been thinking about doing this. Can we get a copy of your code and deploy it on our system? And we're like, whoa, this is held together with baling wire and chewing gum, and it's really not very, very robust there. So we went to the National Science Foundation and proposed a program to them, which they awarded, which was a 3-year, $300,000 program to take what we had kind of prototyped at OSC and make it open source available to the community. And again, we're not creative, right? So it was OSC On Demand. What are we going to name it? Let's call it Open OnDemand.
Open OnDemand. Nice.
A few years after that, again, success just results in more success. We went back to the NSF, got an extension, a 5-year program, $3 million. Nice. And now here we are in 2023. Open OnDemand is kind of the de facto standard now. It's deployed at 400 plus research computing institutions, every continent except Antarctica. I really want to get it at Antarctica, so if somebody can help me get into the NSF data center there at McMurdo, I'd love to hear from you.
You want to go and visit, don't you?
There you go. I do want to visit. I will personally ensure that it gets installed correctly. Yeah.
Because I'm familiar with high performance computing, right?
Sure.
I'm like, so when you talk about on demand, you're not talking about, oh, I have a job and I'm going to go schedule it on there. You're going a level above that.
Yes, exactly. What On Demand does is it's providing that web interface to what you already have on those systems. So, one of the issues, if you look at a lot of students now in college and even grad school, they've grown up not knowing laptops. They've grown up with iPads and cell phones, and they don't know command lines. They don't.
I know, that's a shame.
It is. But it's,
we could even get into debate on VI or Emacs in this discussion.
Yes, we could. Right. Hey, I'm Nano all the way. Okay.
Oh, great. Oh, that's awesome. So yeah, this is an interesting concept because I've seen it with my own kids as they're moving into the workforce in computer science and electrical engineering. I did a poor job. I didn't teach them Linux. They don't know the command line. They're like, "Where's the interface?"
Exactly.
I'm like, well, you actually use the keyboard on your laptop.
Yep.
So that's a big problem that this is helping overcome.
That's exactly right. It's we like to say any device, anywhere. I've got video of me logging into the OSC instance of On Demand from my in-car browser on my Tesla car and running Jupyter and MATLAB in my Tesla. I mean, it's literally, I like to say we actually several years ago saw a grad student send us a picture. The grad student was sitting in a bar with their cell phone in one hand, logged in, monitoring some jobs they were running, and a pint of beer in the other hand. Now, at least here in Ohio, it's not illegal to drink and compute, but we don't necessarily condone doing that there. But that's what this really does. Is it helps to make it easy to utilize these resources.
So can it provide, because it sounds like with the Edison welding, when you guys were doing simulations for them, you provided an abstraction layer even above that where they could say, hey, here's my welding type of simulation I want to run, and I want to see the results.
Yep.
So you're providing even above the job scheduling level.
That's correct.
Right?
Yeah. Many of the people that utilize this don't know anything about job schedulers or anything like that. Yeah. And we've seen an impact. Just talk a little bit about the result of this. This would have been unheard of 5-10 years ago, but here at OSC, we've got our anthropology students that are using us, political science professors that are using us.
Poli-sci's using a high-performance computer.
Horticulture and crop science classes.
Wow.
I mean,
right, yeah,
you know,
guys
so it's
really making it really
and
easy
it's because
to use.
they wouldn't. they wouldn't get into the command line, but they all these groups now have data that they need to do stuff with, and they need to analyze and process, and we abstract that out. That really is what helpful to them.
All right, so this is obviously driving up demand for the use of the supercomputers that you guys have.
Yep.
Right. I mean, so what are you guys running? Are you guys running out of compute space? Because I can imagine if you open this up to every department in the college, everyone's going to go, "Oh yeah, I'm going to use that."
Yeah. So our mandate is actually from the state legislature here in Ohio to provide resources to all Ohioans, both academic and private industry. Last fiscal year, we had 8,500 individuals utilize our systems.
Wow.
Those are from about nearly 400 distinct organizations all over the world, actually. All over the world. And one of the cool things about it is that it does facilitate, and another one of these, be in the right place at the right time. Well, we were in the right place at the right time back in the late aughts. We were also really in the right place at the right time during the pandemic, because I can't tell you the number of institutions. Just last week, I heard from an institution that said it was so wonderful that we had OnDemand installed at the start of the pandemic, because so many students couldn't go onto campus and access computer labs, and they could get virtual desktops through OnDemand on our systems. It just helped so many universities continue to teach and research while the pandemic was going on. People couldn't be in person, and nowadays it seems like, of course, it's obvious.
Yeah, no.
Why do you need to be on campus?
Yeah, exactly. This is really a huge success story.
Yeah.
So all right. So pricing models, if you can talk about it. If not,
sure, absolutely.
we won't. I mean, because this is not a cloud. This is a supercomputer. This is not. Oh, I'm going to go right. So are you guys using? And maybe we can go all the way back to SunGrid Engine. I know you know who they are.
Yeah.
And when they first started, they had a business model that didn't do very well because they were charging on traditional HPC charges, which is CPU time, not clock time. So are you guys doing the old CPU time? I mean, how do you charge
let me talk.
use of this?
And I do want to emphasize that Open OnDemand itself, no charge, fully open source. So any site, anybody can deploy it. There's no cost associated with that. That's not that. But here at OSC, we do have pricing set for, we charge for core hours and we charge for terabyte months. One of the nice things about what we're able to do is, because we are so highly subsidized by taxpayer dollars, if you are an Ohio-based academic entity, basically 80% of your cost is subsidized by taxpayer dollars. So we know down to a thousandth of a penny how much a core hour costs on our systems, and we can charge for that. The other nice thing about this is, because we're the government and have a mandate to provide industry, we can set whatever price we want for commercial industry. And so, I like to say we were the cloud. We are the cloud. We were the cloud before the cloud.
I know. Yeah.
We had last year, we had something like 50 or 60 active commercial accounts that utilized us. Some names that you'd recognize, folks like Procter and Gamble and Honda, names that you wouldn't recognize. And we deliberately set our pricing to undercut the commercial clouds. Now,
you guys do a different type of work.
That's exactly right? Yes. Yeah. So there are a lot of times where somebody comes to us and says, "Can I do this?" We say, "No, you really need to go to one of the cloud providers."
You don't want to run an email server in
exactly,
an HPC cluster.
Exactly. But if you want to do large scale, I mean, one of our and some of our clients we can't talk about, some of them we can.
Right.
We do release case studies. One of our largest clients is a company called Spire. They have a fleet of microsatellites orbiting the Earth, and they are doing weather modeling of the entire Earth, mainly for like transportation companies, shipping companies, because sure, you can get a weather model of what's going to happen here in Ohio. We had tornadoes yesterday. We knew that. If you're in the middle of the Pacific, but if you're a shipping company, you want to know that. If you're an airline, you want to know that. So they're a good example of a customer that they've got that data coming in, and the weather forecasts that they are providing to their clients every 4 to 6 hours are being generated on our systems.
Okay, so these are pretty traditional high-performance computing workloads that you're running in your clusters. have you seen any new or emerging ones because now it's easier to use that you're like going, I never would have thought, but it totally makes sense?
So I mentioned earlier the poli-sci. Fascinating studies that were done a few years ago, right? After the pandemic started, where one of the Ohio State researchers was analyzing the tweets of congressional members relative to COVID, of course, yeah, and doing all kinds of interesting analysis around the language that was used depending on what party somebody was in and all of that stuff. That's one of those ones. Who would have thought? But the intersection of HPC and Twitter and COVID. I mean, who would who would have thought there? I mentioned earlier, anthropology and horticulture and crop sciences. I mean, we've got folks that are developing new models. So Ohio is an agricultural state. It's known as, an agricultural state. And one of the things that's very commonly grown here are soybeans. And there are issues with things called crop rot, certain fungus diseases that infect the fields. And so, there's all kinds of interesting analyses that researchers are doing around trying to combat crop rot, try to, breed new strains that are resistant to that. And so that's the kind of thing. Who would have thought that people were doing that on our system, on supercomputer systems?
That's pretty cool. So, if I were to determine, because you've made it easier to consume, and that's why the cloud took off. Let's just be brutally honest, right? Yeah. They took the stuff we did back at the turn of the millennium with grid computing, and they made it easy to consume with a really kick-butt business model that made them tons of money.
Yep.
Right? All right. So if I'm looking at now we've made it easy to consume HPC, and if I'm looking at work I'm doing right now, what sort of characteristics would I have in my workloads that would say, I need to go to one of the high-performance computing centers in the United States or Ohio Supercomputer Center and say, I'm going to run my workload
I'm going to be a bit glib here and say anything. I mean, I'm going to give you a precise example of why I relates to anything. Several years ago, this is 8 years ago or so. I've lost track of time because of the pandemic. It might be 10,
I know which one.
We were out talking to a company here in Ohio that manufactures plastic bottles, like your water bottles, your disposable water bottles. And we were just kind of talking to them about, well, do you need to, maybe we could provide a service to you. And their engineers were like, no, we're all good. And I was like, okay, well, just tell us a little bit about what your workday looks like. And one of the engineers said, well, I've got this nice beefy workstation right here. I need to, and I'm trying to design new models. I need to come up with my new mesh of a new model by about 5 p.m. so that I can start the solver running overnight. Because it's got to run overnight so that it's ready at 9 a.m. the next day. And then I can look at it and analyze this. And, but it's all good. And I was like, what if we could help you instead of running that overnight, we run that over your lunch break or a coffee break? And to them, it was like, well, that's not even possible. Yes, it is. That's the kind of thing. So really, if there's anything that you do that you are saying
that you batch up overnight,
you batch up time limited, or you're not looking at as many parameter sweeps as you want to because you just can't handle it, or there's too much data and you have to be throwing stuff away. That's all stuff that's ripe for high performance computing and research computing capabilities.
And since you've made it easy to do now, this is going to be so much accessible. So all right, next question I have: do you see the demand growing huge enough where you're going to have to add more capacity?
We're constantly adding new capacity.
Oh,
yeah.
You are? Okay.
Yeah. So right now we have about 55,000 cores, all Intel, by the way.
Thank you very much.
Sorry, take that back. We have 53,000 Intel cores. We have 2,000 from another company that I forgot that we just got those 2 or 3 months ago. We have about 400 accelerators, and that's spread across about 1,600 nodes. We're about to do a new acquisition that's probably going to get us up to 75,000 to 80,000 cores. There's constant demand. Our systems sit regularly at 80% utilization.
Wow, that's incredible.
Yeah, it's there's just the demand is constantly growing. And where it's really growing is in a lot of the biomedical fields. One of the big growing things that we're starting to have to deal with are things like cryo-EM, so cryo-electron microscopy. It's a wonderful tool that's become more and more available to biomedical researchers that generates just volumes of data. And everybody seems to be wanting to analyze that data. Hundreds of terabytes are coming out of these devices. Yeah. Yeah.
So that's a big play. Now, how much? Let's talk about data, because high performance computing is known for lots of data movement. So how much data are we talking about? Do you guys have?
Yeah. We have about 20 petabytes, or I'm gonna get technical here, about 18 pibibytes for those of you who want to use the binary one. About 20 petabytes of actual disk storage. So it's a combination of solid state and spinning. Yeah,
I
exactly.
call it spinning rust.
Yes. Yeah. A very, very high performant system. So our main the bulk of that is on a system that is able to have in aggregate somewhere on the order of 350 gigabits per second of write in there. And that's important because we need people to be able to process and retrieve and write that data very, very fast. So it's very common for us to have researchers come to us with multi-hundred terabyte data sets that they want to put on our system or process, and we're happy. It's really funny because all the time my colleagues and I get new clients coming in and say, well, we've got some really big data, can you handle it? And we're like, well, tell us what you're being really big data. And they'll go and they'll say, oh, it's about 10 gigabytes. I'm like, okay, when it gets to 100, let's talk. I mean, to be frank, every client that comes in, I mentioned it's 8,500 clients. Every client gets a home directory on our systems that's 500 gigabytes that we just give to them. Don't even think about it. It's just there. So it's a different perspective, but it is very, very large data sets. I was just having a conversation today with somebody who, on a daily basis, they need to bring down or send up close to 100 gigabytes. And they're like, is that gonna be a problem? I'm like, no, it's not. We've got a 40 gigabit connection to our main backbone going out of the building. I can handle 100 gigabytes a day.
You can handle that. No problem. Well, and that's another interesting thing. A big cost in doing high performance computing is the movement of data, which is very cost ineffective in typical cloud, because they charge you for ingress and egress costs. I always call them the Hotel California.
Yep.
Right? You can check in, but you can't check out.
Yeah.
For you guys, are there egress costs? All right. So that's pretty smart, right?
Yeah, exactly. And the part of the reason why we're able to have no egress costs is because so let me go back a little bit to the founding of OSC. I mentioned earlier, OSC was founded in 1987. And actually, let me tell the real story. The mid 80s, these things called supercomputers, HPCs, really popular. National Science Foundation said, hey, we need to fund some national supercomputer centers, just like we fund radio telescopes and Antarctica. So they put out a call to fund some national centers. A group of Ohio faculty members put together a proposal. And for those of you that are in the know, we didn't win. The national centers are San Diego and Pittsburgh and Illinois. Well, those faculty members took that proposal back to the state and said, well, the federal government won't fund it. Will you fund it? And the state said, yeah, this is a good idea. We're going to fund this for the state of Ohio. Now, that happened, and they said, okay, we're going to create this entity. Let's put it at Ohio State University here in Columbus in Central Ohio. It makes sense. OSU is the largest university in the state. Very shortly thereafter, a lot of the faculty members around the state said, wait a minute, you've created this supercomputer for us, but this thing called the internet doesn't exist yet. We don't want to have to drive to Columbus to use it. You need to help us out. And the state said, you're right. We're going to create something we call the Ohio Academic Resource Network, ORNET. And the whole purpose of ORNet when it was created in 1987 was literally dial-up modems connected to T1 lines, connected to the Cray supercomputer. So researchers at Case Western and University of Cincinnati and Miami and Ohio University could dial in over their
awesome.
Yeah. So then that was the late 80s.
The poor man's ARPANET.
That's exactly what it was. Yeah. So then in the mid 90s, I already mentioned it. This little thing called the internet was invented. We had the .com boom right around 2000, .com bust, and ORNet had the brilliant idea of basically for pennies on the dollar buying the right to fiber that was laid all over the state. So ORNet now has the right to something like 1,600 miles of fiber throughout Ohio, and every non-commercial entity in the state, so every university, K through 12 school, hospital, PBS station, state agency, driver's license bureau, they all connect to that backbone. ORNet is the main backbone in Ohio that then connects to AT&T and Comcast and Spectrum and all those. But basically we run a high level 100 gig to 400 gig backbone here in Ohio, and that's what allows OSC to not charge any type of, because we have that connectivity.
That's kudos to whoever set that up.
Yes.
That's saving the state and university lots of money. This is truly fascinating. Where do people go to learn more about on-demand or Open OnDemand or Ohio Supercomputer Center?
So openondemand.org, it's right over your shoulder there, but if people are just listening, they can't see it, so it's all one word, openondemand.org for Open OnDemand. And that's for if you want to see if we have on there both if you're a research computing site that wants to deploy it, but also if you're just a client and want to figure out where can you play around with, or maybe does your research computing site access it. I'll say all the major commercial providers, Microsoft Azure, Amazon AWS, and Google Cloud, they all have on-demand available on their sites. So you can, So if you do openondemand.org/AWS, it drops you right into the Amazon on-demand. You can just spin up in AWS. openondemand.org/Azure, openondemand/
Oh, really? I could just hop on a CSP and start up a cluster.
Absolutely. You can spin up. Sure, but you can spin up as you want virtual HPCs with on-demand and an interface that each of those providers have created. So that's Open OnDemand. And then if you want to learn more about OSC, Ohio Supercomputer Center, it's osc.edu. And if you go to our webpage, again, it's not OSU, it's osc.edu. In the upper right-hand corner of the menu bar, there's a Get Access, and it talks a little bit about how to get access to us and some of the pricing associated with it.
Oh, very cool. This is wonderful. And this has been wonderful to actually sit and talk to a human being instead of just via Zoom.
Yes, it's been great. And we're next to each other, just so you can see, so we can wave. In case everybody thinks that we're faking this. No, we're right here.
Yeah, right. Thank you so much for your time.
Hey, pleasure. Thank you so much for having me do this, Darren.
Thank you for listening to Embracing Digital Transformation today. If you enjoyed our podcast, give it 5 stars on your favorite podcasting site or YouTube channel. You can find out more information about Embracing Digital Transformation at embracingdigital.org. Until next time, go out and do something wonderful.